Hello and welcome to another Orange Coast College mathematics video. In this video, we're going to learn how to find the domain and range of a function if we are given its graph. Now, I'm going to assume that you're familiar with interval notation and the idea of functions in general. Now, when we're talking about the domain of a function y equals f of x, what we mean here is all of the numbers that we're allowed to plug into the function. When we say allowed to plug in, we mean that plugging it in won't make us inadvertently divide by 0 or take the square root of a negative number, stuff like that. Now, the range are all of the y values that we would get for any possible choice of x. So if you look at all the possible x we can plug in, all of the values y that you get, that's the range. Example 1. Now here's our graph. And so the domain is just all of the x values that we can plug in, or all of the x values that we have for this function. So the way we do this is we simply look at our x-axis here, our horizontal axis. And we're going to look at what are the x values that our graph lie above. So if we look at this, right, we just draw a line straight down to here. This starts at 4. So what we're going to do is we're going to actually just draw a little picture here. So at 4, I'm going to put a little bracket since we include the point x equals 4 because this dot is solid, right? It's a solid dot. So we're including that point. It's like 4, 8. And then we simply draw along the x-axis to cover all the values that this graph lies above until we get to here. Now, you notice that second point there at the end of the graph is an open circle. It means we don't include that point, but we include everything up to it. So we're going to put a parenthesis here. And so that's from 5 to 8. So our domain is from 5 to 8. And so we include the 5, but not the 8. To find the range, we do the exact same thing, but now for the y-axis. So we look at the y-axis, and our first point on the y-axis we lie is right here. That is 2. We're going to use a parenthesis, again, because that endpoint is not included. Then I'm just going to trace up the y-axis until I get to here, the highest point on the graph. And since we do include that point, I'll put a bracket. And so this is from 2 to 8. So the range is, we don't include 2, but we do include 8. And you'll notice here, right, make sure when you're in interval notation, you write from the smallest value to the largest value. So from 2 to 8, okay, even though from here, right, it was from 5 to 8. Okay. That's it. Example 2. So this problem is a lot like the previous one. It's just that we have one small difference. So again, you go from left to right. We find the domain. You look at the x-axis. Where does the graph lie above the x-axis for what values of x? We start from left to right. So we start right here. This is the leftmost point, and the graph lies above this. And really, this arrow right here just means it goes on forever. So even though it stopped drawing it, right, it just goes off forever. So since this x-axis extends to infinity, so does the graph. And so basically what that means is I'm going to put an arrow right here to just denote that that's going to go on forever. So the domain would just be from 5 to infinity. I'm going to put a parenthesis there since infinity is not a number, we can't include it. There was no dot on the end of the graph here, just the line sort of stopped. We'll just assume that means we include that point. Okay. Now for the range, we do the same thing, but now we do it along the y-axis from the smallest value, the lowest point on the graph. That's right here, right? And then go all the way up. And again, because this has an arrow here, we can kind of just assume it keeps going up. It goes up and to the right forever. And that means our range is going to go all the way from 0 up to infinity. So our range will be 0 to infinity. Example 3. Okay, this graph has an interesting feature, which is that it has what's called a vertical asymptote. You can see, if we look at the y-axis here, okay, as the graph approaches the y-axis from the left and from the right, the graph is nearing the y-axis, but it's never going to intersect it. So what that means is because the graph, if you look at this graph, it's going to extend off into negative infinity to the left and to positive infinity to the right along the x-axis. Every single x value on the real axis is going to be included in the domain except for 0, because the graph never intersects x equals 0, which is the y-axis. So if we trace along the x-axis, where does this graph lie? It's going to go off to the left to infinity, negative infinity. It's going to go up to 0, but we're not going to include it, so we're going to put a parenthesis there. And then same thing, but from the other side of the y-axis. So it's going to be at x equals 0, we have another parenthesis, and then it's going to extend off to positive infinity to the right. So if I want to write the domain here, the way we write this is it's negative infinity, again, not including negative infinity, so we write a parenthesis, up to 0, and we put a parenthesis here. That parenthesis means we do not include 0. And then what we do is we use this symbol, which is for union, and then we write 0 to infinity, again with parenthesis at 0. What this really just means is this is basically just how we write out this set, because it's the left half of the x-axis and then the right half of the x-axis, but we do not include 0. And so this is just the way in interval notation that we can write all x except for 0. Now to do the same thing for the y-axis, you'll notice it kind of has a similar symmetry that we had before here, which is that if we start from the bottom, right, every y up until we get to 0 will be included, because this is never going to intersect the x-axis. So basically every y is covered here except for y equals 0, the x-axis, and same thing for above. So if we trace this out, it's going to look like this. Everything, we put an arrow here. Up to here, we put a parenthesis because we don't include y equals 0. And again, we do the same thing. So it's going to be almost identical to when we found the domain. So the range will be actually the same as the domain. So it's going to be, again, negative infinity to 0, put a parenthesis at 0, and then we union 0 to infinity. So again, that's the way we say basically all y values are taken except for y equals 0. We cannot be y equals 0. Example 4. Now for the domain for this one, because these arrows here and here, this graph just extends off into infinity. And even though it's going up, it's going to go to the right off to infinity. So essentially it's going to go to the right forever. And it's also going to go off to the left forever. So the domain of this function would be all real numbers. And the way we can write that, because every single x value is covered, the way we write that is just negative infinity to infinity. That's how we can write that in interval notation. Now, as for the range, again, we just trace along the y-axis. So the smallest y value it takes on is down here at -3. And those arrows, we have arrows here. So this is going to go up to infinity in both directions. So the range will just be all numbers larger than -3. So basically, it's going to go up to infinity here. So the range, if we looked at all the values along the y-axis, it's going to go from -3 up to infinity. Example 5. Again, kind of like in the last problem, we have these arrows, right? The graph is just going to go up and to the right. Because it's a function, it can't have two y values for a given x value. So this arrow going up, it looks like it's kind of getting steeper, and it is, but it's always going to be moving to the right. And also, this is going down in this direction, it's always going to be moving to the left. So the domain in this instance is just going to be all real numbers, or from negative infinity to positive infinity. Okay, if we were to trace along the x-axis, right, every single value along the x-axis would be hit. This graph would lie over the entire x-axis if we could draw the entire graph. Okay, and it's the same for the y-axis, for the range, right? It goes up to infinity down here, goes down to negative infinity here. So the range is also negative infinity to infinity. Here's our final example. So for the domain, right, because this graph, again, we have arrows here, it's going to continue on like this. So it's going to continue going. I mean, essentially, this is the graph of the function like 5, like a sine function. So, we can kind of continue. It's probably going to continue moving like this. But the important thing is this arrow just means that it has to continue at least in that direction forever. So the domain of this, if we were to draw the entire graph, it would lie along the entire x-axis. So the domain, if I were to just graph it along the x-axis, would look like this. So the domain is going to be all real numbers, or in interval notation, negative infinity to infinity. Now the range, we look at the y-axis. Where does the graph lie along the y-axis? The smallest value is at -5, and we can just trace up. It lies along there until the highest y value, the largest y value, is at +5. So for this one, the range of this function is going to be from -5 to 5. Okay. Notice because the graph does take on this value here. What is that? 2, 5, right? Y equals 5 is a valid, it's a value that this function can take on. And same thing with -5, which is why we're using brackets here. And that's all. And that's it for finding the domain and range of a function given its graph. Now, this isn't the most challenging sort of problem you'll come across in math class, but they can definitely be tricky at first. So try to do as many kinds of problems as you can find. You can also just, if any kind of function where if you're looking at a math textbook and you have a graph, you can always just mentally say, well, what's the domain and range of this? And you can get the practice that way as well. All right, until next time, have fun.